Hey guys, tonight we begin with a thought that drifts far beyond the familiar edges of our history books. What if Earth's first civilization wasn't human? It's a question that floats somewhere between science and wonder, between fact and imagination. When we look at the Earth, with its deep oceans, shifting continents and hidden fossils, we realize how much of its story is still untold. The Earth has been alive for billions of years, yet humanity has only existed for the smallest fraction of that time. What happened before us? Could there have been intelligent beings who rose, thrived, and vanished long before humans set foot on this planet? Before we settle in and begin our peaceful journey, take a moment to like this video and subscribe, only if what I share here truly resonates with you. Your support helps me create more of these videos, and if you feel like it, let me know where you're tuning in from and what time it is. It's always fascinating to see the many corners of the world where we connect. Now, dim the lights, make yourself comfortable, and let's ease into tonight's journey together as we explore what lies ahead. Chapter 1: The Vast Timeline of Earth. To imagine whether Earth's first civilization wasn't human, we must first step back, far back, into the deep timeline of our planet. Picture the Earth not as we know it now, but as a world in constant transformation. Earth formed around 4.5 billion years ago. At first, it was not a welcoming place. The surface was molten, battered by asteroids, and wrapped in a toxic atmosphere. Yet over time, the chaos gave way to balance. The first oceans appeared, clouds gathered in the sky, and somewhere in that ancient water, life began. When we think about civilizations, we usually imagine human ones. Cities of stone, roads, tools, and writing. But Earth's timeline reminds us that humans only appeared about 300,000 years ago. That's just a blink compared to the billions of years that came before. For context, if Earth's history were compressed into a single 24-hour day, humans would have arrived in the last few seconds before midnight. This means there were vast stretches of time, billions of years, when other forms of life could have risen and flourished. Life didn't need to look like us, or think like us to build something remarkable. Civilizations might not always mean skyscrapers or metal. They could mean vast colonies, networks of communication, or intelligent patterns of survival. Let's pause here and imagine. The Devonian period, some 400 million years ago, is often called the Age of Fishes. Oceans were alive with strange creatures, many now extinct. On land, early plants began to take root, and forests slowly formed. Could there have been beings, perhaps aquatic, perhaps land-based, that developed intelligence we can barely recognize today? We don't know. Fossils are clues, but they are incomplete, and so much of Earth's story remains hidden beneath layers of rock and ocean. This mystery gives rise to what scientists sometimes call the Silurian hypothesis. It asks, if a non-human civilization had existed millions of years ago, would we even know it? Over time, the Earth recycles itself. Erosion, tectonic shifts, and volcanic eruptions erase almost everything. Our own modern world, our cities, our roads, even our satellites, would mostly vanish within just a few million years. The traces of our existence would fade. And so, when we ask whether Earth's first civilization wasn't human, we are really stepping into the vast silence of deep time. We are acknowledging that the Earth has had more time without us than with us. And within that silence, anything may have been possible. Chapter 2: Fossils, Forgotten Worlds, and the Silence of Deep Time. When we try to imagine whether Earth's first civilization wasn't human, our minds naturally drift toward fossils. Fossils are the memory of the Earth. They are the impressions of bones, shells, plants, and even delicate imprints of leaves pressed into stone. They're the closest thing we have to a diary written by the planet itself. But here's the thing, fossils are rare. They don't form easily. For a living being to become fossilized, very specific conditions must be met. A creature must die in just the right place, perhaps in the mud of a riverbed or the sand of the ocean floor. It must be buried quickly before scavengers can scatter its remains. Over thousands and millions of years, minerals replace bone and flesh, preserving the form within stone. Out of the countless living things that have ever existed, only the tiniest fraction become fossils. This means that most of Earth's life story is missing from the fossil record. It's like trying to read a book when most of the pages are gone. We fill in the gaps as best we can, but so much remains unknown. Now imagine if there was once a civilization that rose millions of years ago. A civilization not made of stone and metal, but perhaps of materials that vanish quickly. Organic structures, coral-like towers, or something entirely unfamiliar to us. Would those traces survive? Probably not. Time, weather, and geology are relentless erasers. What we see today is only what happened to be preserved by chance. Scientists point to this mystery when they consider the possibility of forgotten worlds. A well-known idea in this field is the Silurian hypothesis, first formally proposed by astrophysicist Adam Frank and climatologist Gavin Schmidt. The name Silurian comes from an era around 400 million years ago, long before humans, when strange creatures dominated the seas. The hypothesis doesn't claim that such civilizations existed. It simply asks, if they had, would we even be able to detect them now? Their answer is both humbling and unsettling. It would be very difficult. Think about our own civilization. If humans disappeared today, how long would our cities last? Buildings crumble, metals corrode, plastics degrade, and glass shatters. Within a few thousand years, forests would reclaim highways, and rivers would carve through cities. In just a few million years, the traces of our world might be nearly gone. The only clues might be subtle changes in the chemical makeup of the soil, odd layers in the rocks that suggest something unusual once happened here, like sudden shifts in carbon or evidence of mass extinctions. And indeed, when geologists dig into Earth's past, they do find odd layers. They find spikes of carbon, oxygen, and other chemicals that suggest massive changes in the environment. Some of these were caused by natural events, volcanoes, asteroid impacts, or sudden climate shifts, but others remain puzzling, leading us to wonder, could they have been the echoes of something more? Let's pause for a moment and imagine a forgotten world. Picture an ancient Earth, tens of millions of years before us, where the continents were arranged differently. The air was warmer, and forests stretched across regions now buried under ice. Perhaps in that world there were beings, not like us, not with cities of glass and steel, but with their own way of shaping the land, communicating and leaving behind traces of order. Maybe they carved patterns into stone or wove vast networks through the oceans, much like corals do today. Over time, those traces would dissolve, erased by floods, winds, and tectonic plates shifting beneath our feet. It reminds us of something important. Absence of evidence is not always evidence of absence. The Earth has a long memory, but not a perfect one. There's another story worth considering here, one that ties fossils to the possibility of intelligence in surprising places. In the Cretaceous period, around 70 million years ago, dinosaurs ruled the Earth. Among them was a small bird-like predator called Troodon. Troodon was remarkable because of its brain size. It had one of the largest brain-to-body ratios of any dinosaur. Paleontologists have speculated that if it hadn't gone extinct, it might have evolved further, perhaps even toward a form of intelligence. Canadian paleontologist Dale Russell once imagined what such a creature could have become, a dinosauroid, a reptilian being with advanced capabilities. It was a thought experiment, not a claim, but it shows us how life has the potential to surprise us. So when we think of fossils, we realize they're only fragments of a grand puzzle. They show us glimpses, but never the whole. And in those missing pieces, those long, empty stretches of silence, our imagination begins to wander. Could civilizations have risen and vanished, leaving behind no clear trace? The fossil record cannot answer us completely. It is quiet, incomplete, and full of unanswered questions. In this way, fossils are like whispers from the earth. They tell us just enough to know that life has always been full of possibility, but never enough to say with certainty what that possibility might have looked like. Chapter 3. Mass extinctions and the possibility of lost civilizations. To understand whether Earth's first civilization might not have been human, we must explore one of the most dramatic forces shaping the planet: mass extinctions. These are the great resets of life, the moments when Earth seems to wipe the slate clean, clearing away old forms and making room for new ones. Throughout history, there have been 5 major mass extinction events, and perhaps a 6th underway today. Each of these moments drastically reshaped the balance of life, and within these resets lies the possibility, however faint, that civilizations may have risen and been swept away, leaving almost nothing behind. The first of these, the Ordovician-Silurian extinction around 440 million years ago, was likely caused by dramatic shifts in climate. Vast ice sheets formed, oceans withdrew, and shallow marine habitats collapsed. About 85% of marine species disappeared. If anything resembling a civilization existed in that ancient sea world, it would have been erased without mercy. The second great extinction, the Devonian extinction roughly 370 million years ago, was slower, stretched across millions of years. It targeted life in the oceans again. Coral reefs collapsed. Whole lineages of fish disappeared. Scientists believe changes in sea levels, oxygen depletion, and even asteroid impacts played a role. Imagine if an ocean-based civilization had existed, beings that lived within reefs, perhaps creating elaborate structures of shell and stone. The Devonian extinction would have dismantled their world piece by piece until nothing remained. Then came the most catastrophic of them all, the Permian-Triassic extinction about 252 million years ago. Known as the Great Dying, it erased over 90% of species. Entire ecosystems collapsed, from the smallest microbes to towering forests. The cause was likely a combination of massive volcanic eruptions, runaway greenhouse gases, and ocean acidification. If we imagine a civilization existing at this time, its end would have been beyond comprehension. Imagine cities, if there were any, drowned in toxic seas, lands buried under volcanic fire, skies blackened for centuries. Nothing would have survived long enough to leave behind enduring traces. The fourth, the Triassic-Jurassic extinction about 200 million years ago, cleared the way for dinosaurs to dominate. Climate shifts, volcanic activity, and asteroid impact again played a role. Perhaps if intelligent reptiles or amphibians were experimenting with order and culture, their timeline ended there, swept away before it could take hold. And then, most famously, the Cretaceous-Paleogene extinction, 66 million years ago, when an asteroid struck Earth and ended the age of dinosaurs. In that fiery impact, 75% of species vanished. But this event also gave rise to mammals, and eventually to us. It's sobering to think that if intelligence had been blooming in some reptilian form, in some small corner of that world, it may have been silenced forever in that single violent moment. Mass extinctions remind us of two things. First, that Earth is not a gentle caretaker. She is dynamic, unpredictable, and sometimes destructive. Second, that life has an astonishing resilience. Every time the Earth has been emptied, new forms of life have emerged to take the place of what was lost. But here is the question that lingers in the quiet. Could civilizations, non-human ones, have risen in the spaces between these extinctions? There were millions, sometimes tens of millions of years of relative stability between these catastrophic resets. For example, the age of the dinosaurs lasted for more than 150 million years. Humans, by comparison, have existed for only a few 100,000 years. If it takes only a few million years for a species to evolve from simple beginnings into complex intelligence, then there was time and plenty of it. And if any such civilization existed, mass extinction events may have been their undoing. An asteroid strike or a global volcanic winter would erase not only their lives but also their memory. Over millions of years, wind, water, and shifting continents would erase their works until nothing recognizable remained. There is a poetic sadness in this. Imagine a civilization that thrived not in glass towers, but perhaps in living forests, building with organic matter that never fossilized, or an ocean-dwelling intelligence that left patterns in coral or sediment. The moment the Great Dying came, their presence would vanish, their achievements dissolved into the silence of time. Mass extinctions are like the Earth's punctuation marks, full stops that end one chapter of life and begin another. If civilizations rose before us, they were perhaps written into chapters now erased, stories we can no longer read. And as we reflect on this, it makes us wonder, will our own chapter someday vanish in the same way? If future beings dig through the layers of Earth, will they find us? Or will we too be erased, like countless others before? For now, the answers remain hidden, buried deep in stone and silence. But mass extinctions show us just how easily civilizations, human or otherwise, could vanish without a trace. Chapter 4: Climate Cycles, Shifting Continents, and the Hidden Clues of Lost Civilizations. When we think about Earth's history, we often imagine it as a long, steady journey from chaos to order. But the truth is far more dynamic. The Earth has never been still. Its climate has risen and fallen like tides. Its continents have wandered like drifting islands, and its oceans have appeared and disappeared many times over. To understand whether Earth's first civilization might not have been human, we must look closely at these great cycles of climate and geology, forces that shape, erase, and sometimes even hide entire worlds. Let's begin with the Ice Ages. Over the last few million years, the Earth has entered repeated cycles of glaciation. Massive ice sheets spread across continents, grinding mountains into valleys, reshaping rivers, and burying entire landscapes. If our own civilization were caught in such an age, many of our cities would vanish under kilometers of ice. Concrete would crack, steel would bend, and even monuments like the pyramids would one day crumble. After the ice retreated, the land would appear fresh, scoured, clean. Now imagine if there had been a civilization before us, perhaps hundreds of millions of years ago, during one of these ancient glacial cycles. The movement of ice, combined with melting floods, would have erased nearly every trace of them. The glaciers are both destroyers and keepers of secrets, carrying stones, soil, and sediment far from where they began. Whatever stood in their way would be lost in the slow grinding of time. Beyond the Ice Ages, the Earth also passes through greenhouse worlds, periods when the planet was far warmer than it is today. During the Mesozoic era, when dinosaurs thrived, there were no polar ice caps at all. Vast forests spread to the poles, and sea levels were hundreds of meters higher than today. If civilizations had lived then, their landscapes would have been very different. Entire cities, or the equivalents of them, might now rest beneath the ocean floor, buried under layers of sediment. This leads us to another powerful eraser of civilizations, plate tectonics. The Earth's surface is not fixed. Its crust is broken into plates that drift slowly across the globe. Mountains rise when plates collide, while oceans widen when they drift apart. Over tens of millions of years, continents shift like pieces on a puzzle board. This process means that even if a civilization once existed on a long-lost continent, it could now be gone forever. Entire land masses, such as the ancient continent of Gondwana, were swallowed into the Earth's mantle. Others, like Zealandia, are now mostly submerged beneath the Pacific Ocean. A forgotten civilization, if it had risen on one of these lost continents, might now be buried beneath kilometers of water or melted into the deep crust, impossible for us to find. Geology also leaves subtle chemical clues, whispers of what once was. For example, when we dig into the Earth's layers, we sometimes find unusual deposits of carbon or metals that hint at dramatic changes in the environment. Today, human civilization leaves its own chemical fingerprints, plastics, synthetic compounds, radioactive isotopes. If another civilization existed millions of years ago, their equivalent fingerprints might still be hidden in the rocks, but we would need to know exactly what to look for. This brings us to a fascinating point. How we define a civilization may shape whether we can even recognize one from the past. We look for tools, buildings, writing, and art. But what if an earlier intelligence shaped its world in ways we don't recognize? Perhaps they grew forests into deliberate patterns, cultivated oceans, or used biomaterials that vanished without a trace. Their cities may not have been stone and metal, but living organisms, structures that dissolved when they were no longer tended. Stories from human culture remind us how fragile memory can be. In mythology, we often hear of lost worlds, Atlantis, Mu, Lemuria. These tales may not be literal, but they echo humanity's awareness that civilizations can vanish. They remind us that memory is always incomplete, and that what is gone often feels like it has slipped just out of reach. Science shows us that Earth's own memory works in much the same way. Continents shift, climates change, oceans rise and fall. With each cycle, evidence is erased, scattered, and rewritten. If a non-human civilization once walked this planet, the chances of us finding them are slim, but not impossible. The greatest challenge lies in learning how to read Earth's hidden clues, and in widening our perspective beyond the narrow definitions of civilization we know today. Because when we step back and look at the grand story of Earth, we realize that our human presence is just one chapter among countless others. If there were chapters before us, written by beings we cannot yet imagine, they may still be out there, buried in stone, whispered by fossils, or waiting to be revealed by the shifting of the Earth itself. And so, when we walk through forests, climb mountains, or sail across oceans, we're not just exploring nature, we're walking through the memory of the Earth, a memory that stretches back billions of years. Much of that memory has been erased, but some faint traces may still remain, waiting for us to notice. Chapter 5. Imagining non-human civilizations, beyond our human lens. When we think of civilizations, we instinctively picture our own, cities of stone and steel, languages written on paper and screens, technologies built from fire, electricity, and metal. But this is only our perspective, a narrow window shaped by human evolution and culture. If we are to imagine whether Earth's first civilization wasn't human, we must free ourselves from this lens and open our minds to other possibilities. Civilization, at its core, means the organized expression of intelligence. It is the shaping of environment, the sharing of knowledge, and the continuity of culture. But these things do not always require skyscrapers, satellites, or even hands like ours. They can emerge in forms very different from humanity. Let's begin with the ocean. The seas cover more than 70% of our planet and have been home to life for billions of years, long before creatures set foot on land. It's possible to imagine a civilization of ocean dwellers, beings who used currents, reefs, and bioluminescence as their tools. Instead of building with stone, perhaps they sculpted coral, guiding its growth into deliberate patterns and vast structures. Instead of written language, they might have communicated through pulses of light or complex songs carried across the water. In fact, even today, whales and dolphins remind us of this possibility. They have sophisticated communication systems, social bonds, and even distinct cultures within pods. They may not build monuments, but they pass knowledge from generation to generation, just as humans do. If such creatures could exist today, could something similar, yet far more advanced, have thrived millions of years ago, only to vanish without leaving behind material traces? Now, imagine the land. Long before humans, Earth was filled with creatures that lived in vast social groups. Insects like ants and termites are astonishing in this regard. They build towering mounds, cultivate fungus farms, and create complex societies with division of labour. To them, these mounds are like cities, bustling with activity, communication and purpose. If a non-human civilization had once existed on land, perhaps it evolved not from solitary hunters, but from collective builders. Imagine an ancient species that built living structures out of plants, reshaping forests into sprawling organic habitats. Unlike human cities, which scar the land, theirs might have blended seamlessly with nature, leaving no obvious ruins for us to discover millions of years later. We should also consider intelligence not tied to physical construction at all. A civilization might have expressed itself through knowledge, not monuments. They may have mastered the manipulation of ecosystems, the careful balancing of entire environments. Instead of shaping the land with stone, they shaped the balance of life itself, an achievement invisible to the fossil record. And then, there is the possibility of forms so alien to us that we struggle even to picture them. Perhaps a civilization based on fungi spreading vast underground networks of communication. Today, mycelial networks already connect trees in forests, allowing them to exchange nutrients and signals, something scientists call the Wood Wide Web. Imagine if such networks were once conscious, deliberate and organized. An underground civilization that communicated in ways we cannot fathom. Or consider insect-like beings with short lifespans, evolving not as individuals but as collectives. Each generation building on the work of the last, not through writing but through genetic memory, passing knowledge directly into their offspring. Such a civilization might have thrived quickly, burned brightly, and then vanished just as quickly, leaving behind almost no evidence for us to find. What all these possibilities remind us is this: we must not measure civilization only by human standards. Our tendency is to look for stone ruins, metal tools, and writing carved in clay or inked on parchment. But intelligence could take other forms. It could shape environments subtly, invisibly, or in ways that are erased by time. This line of thought is humbling. If non-human civilizations once existed, they may have looked nothing like us, thought nothing like us, and left no ruins we would recognize. And yet, they may have lived full, intelligent lives, exploring, learning, and expressing themselves in harmony with the earth. We are reminded here of a lesson whispered through science and myth alike. Humanity may not be the only possible story. We may not even be the first. Our way of building, writing, and inventing is simply one path among countless others that could have been taken. The earth is vast, old, and patient. Within her long memory, there was more than enough time for civilizations to rise and fall, shaped by logics we have yet to understand. And perhaps, somewhere deep in the earth's hidden layers, or in the unexplored depths of the sea, faint traces still remain. Traces we would only notice if we knew how to look beyond ourselves. Chapter 6. Searching for Traces. Science and the Hidden Footprint of the Past. If Earth's first civilization wasn't human, then the great question becomes, how would we ever know? What clues might they have left behind that could survive the erasing power of millions of years? To answer this, we must step into the quiet world of science, where geologists, chemists, and paleontologists search for faint fingerprints hidden in stone, soil, and ice. The most direct traces of a civilization, tools, buildings, art, are fragile. Over millions of years they crumble, dissolve, and are swallowed by the earth. But civilizations also leave indirect traces, signatures that seep into the environment itself. These are harder to erase, and they may last far longer than physical artifacts. Let's start with chemical markers. Human civilization today leaves behind plastics, pesticides, synthetic chemicals, and heavy metals. These substances infiltrate the soil, rivers, and oceans. Even if our cities were erased, the strange chemical fingerprints of our time would linger in the rocks for millions of years. Future beings studying Earth's layers might one day find a thin stratum rich with unusual compounds and realize something intelligent once lived here. Now, imagine a civilization millions of years ago. They might have used chemicals very different from ours, perhaps ones that no longer exist today. If they developed energy sources, industry, or agriculture, they too may have altered the chemical balance of their planet. Those shifts could still be recorded in the rocks, waiting for us to stumble upon them. Another powerful clue lies in isotopes, variations of elements with different atomic weights. Today, nuclear technology alters isotope ratios in the environment in ways that do not occur naturally. If an ancient civilization had developed nuclear energy or advanced metallurgy, we might detect their presence through unusual isotope patterns locked inside ancient minerals. Then there are climatic anomalies. Human activity today drives climate change, altering carbon dioxide levels in the atmosphere. If a previous civilization had burned fuels, cultivated land on a vast scale, or engaged in activities that altered the balance of gases, it might have left behind spikes in the geological record. When scientists drill into ancient ice cores or examine layers of sediment, they sometimes find mysterious fluctuations in carbon and oxygen. While most are linked to natural events like volcanic eruptions, it is not impossible that some anomalies could be echoes of long-vanished activity. Another area of search is the distribution of metals. Civilizations mine and concentrate metals, copper, iron, aluminum, in ways nature does not. Millions of years from now, unusual concentrations of these metals may stand out as markers of human presence. If a non-human civilization once walked the earth, they too may have left behind strange clusters of metals now buried deep within rock layers. But the most haunting search of all is for patterns, evidence of order within the chaos of nature. Life itself creates patterns, but civilizations amplify them. Straight lines, geometric arrangements, deliberate symmetry. These are the hallmarks of intelligent design. Archaeologists today sometimes discover ancient human structures not by digging, but by recognizing geometric patterns in satellite images of landscapes. Similarly, if a civilization long before us shaped forests, fields, or coastlines, faint patterns might still linger in the geography. Some scientists even turn to the fossil record of extinctions for clues. Human activity has already caused a noticeable decline in biodiversity, sometimes referred to as the sixth extinction. If another civilization had existed before us, they too might have left behind a wave of extinctions, an abrupt disappearance of species in a narrow time window. Such a pattern, buried in stone, could be a subtle signature of intelligence. And yet, there is a challenge. Nature herself produces anomalies. Volcanoes release metals, asteroids change isotope ratios, and climate shifts alter carbon levels. Distinguishing between natural processes and artificial ones is difficult. That is why the search for lost civilizations is as much a philosophical exercise as it is a scientific one. It asks us to consider not only what we know, but what we might not recognize. This brings us to the idea of technosignatures, a term often used in the search for extraterrestrial intelligence. Scientists looking for alien civilizations in the cosmos don't necessarily expect to find radio messages or spacecraft. Instead, they search for subtle signs, unusual energy emissions, artificial chemical balances in planetary atmospheres, or patterns in starlight that nature alone cannot explain. If we apply that same reasoning to Earth's past, the question becomes, what technosignatures might lie buried here, beneath our feet, waiting to be uncovered? Could strange isotopes, unexplained chemical spikes, or unnatural patterns in extinction events be the quiet whispers of an earlier intelligence? The Earth is a keeper of secrets, but she does not give them up easily. Her memory is long, yet imperfect. She buries, she erases, she recycles. And in that constant motion, the traces of any ancient civilization may be faint, scattered, and difficult to interpret. Still, the search continues, not always as a formal scientific quest, but as a curiosity, a gentle wondering. For if we can find even one undeniable trace, a fragment that cannot be explained by natural processes, it would change everything we know about ourselves. It would mean we are not the first to wonder, not the first to build, and not the first to dream upon this earth. Chapter 7. Anomalies in the Rocks. Whispers from Deep Time. When we look at Earth's history, most of what we see is the steady rhythm of natural change. Mountains rise and fall, oceans expand and shrink, species emerge and vanish. Yet here and there, scattered across the pages of geological time, we find puzzles, anomalies that do not fit neatly into the natural order. These strange markers invite questions, and some wonder, could they be subtle echoes of something more? Perhaps the faint traces of forgotten civilizations? Let us begin with the carbon isotope spikes. Deep in the geological record, scientists have discovered abrupt changes in the balance of carbon isotopes. These shifts suggest that vast amounts of carbon were released into the atmosphere in short periods of time. Normally, such changes are linked to volcanic activity or massive asteroid impacts, but in some cases, the source is unclear. For instance, during the Paleocene-Eocene thermal maximum, around 56 million years ago, the Earth experienced a sudden warming event. Carbon levels surged, ocean chemistry changed, and ecosystems were disrupted worldwide. Could such a sharp spike have been caused by natural events alone? Or might it reflect the industrial activity of an ancient intelligence? The mainstream explanation is volcanic eruptions or methane release, but the possibility remains an open, quiet question. Next, there are the mysteries of mass extinctions. We know of 5 great extinctions in Earth's history, where vast numbers of species disappeared in geologically brief moments. The most famous is the extinction of the dinosaurs 66 million years ago, linked to an asteroid strike. But not all extinctions have such clear causes. Some occur with abruptness, and with patterns that resemble human-driven extinctions today. Selective losses of large animals, sudden collapses in diversity. Could at least one of these extinction events have been shaped not by falling space rocks, but by the actions of intelligent beings who lived, thrived, and perhaps overreached long before us? There is also the enigma of rapid climate shifts. In the rock layers, scientists sometimes find evidence of temperature swings that occur far faster than natural cycles normally allow. Ice melts, oceans rise, deserts spread, all in what seems like the blink of a geological eye. Today, humanity is causing such rapid changes, visible in the record we are leaving behind. If our climate-altering activity is so obvious, is it possible that another sharp, unexplained warming or cooling event might represent a lost civilization's footprint on the planet? Another set of puzzles lies within metallic anomalies. In some rock strata, geologists discover unusual concentrations of metals, levels far higher than what would be expected from natural geological processes. Human civilizations concentrate metals through mining, refining, and manufacturing. If another civilization once existed, its mines, its industries, or its artifacts might have been swallowed by the earth, leaving only unusual chemical fingerprints. For instance, layers rich in rare elements, or sudden spikes in aluminum or copper, could suggest purposeful gathering of materials. Nature can produce these patterns too through volcanic processes or asteroid dust, but separating the artificial from the natural is an ongoing challenge. Then there are the fossil mysteries. Occasionally paleontologists find fossils that seem out of place, creatures fossilized in unexpected layers, or shapes that resemble tools, though they're usually dismissed as natural formations. Some claim to have found metallic spheres deep within ancient rock, or imprints that look like shoe prints far older than humans. While most of these are explained as natural oddities, a small fraction remain unexplained, lingering at the edges of possibility. If even one of them were genuine, it would mean that the timeline of intelligence on Earth is far longer and stranger than we imagine. Beyond the rocks themselves, we turn to geomagnetic anomalies. The Earth's magnetic field, recorded in minerals as they cool, tells stories of shifting poles and reversals over time. But there are occasional disturbances in these records, blips that suggest something unusual interfered with the magnetic flow. Could advanced technologies, perhaps even ones that harnessed energy on a planetary scale, leave behind such faint scars? The oceans too keep secrets. On the seabed, scientists find structures that look artificial, pyramidal shapes, terraces and walls. Most are natural formations shaped by erosion, tectonics and currents, but some remain hauntingly geometric. The ocean floor is the least explored part of our world. If an ancient civilization existed, and if it fell long ago, much of its story could now be buried beneath miles of water, hidden in the silent deep. It is important to remember that mainstream science does not claim these anomalies are proof of lost civilizations. The simpler explanations, volcanoes, asteroids, ice movements, are far more likely. But what makes these anomalies fascinating is that they could be interpreted differently. They open a doorway for imagination, for gentle speculation. They allow us to wonder whether we are truly alone in Earth's long history, or whether we are simply the latest in a series of civilizations, each rising and falling in turn, each leaving faint whispers in stone. As we drift deeper into this thought, we can almost imagine future beings studying Earth millions of years from now. Perhaps they too will puzzle over strange anomalies, our plastics turned to stone, our buildings ground into mineral dust, our chemical fingerprints embedded in the soil. They might wonder if a civilization once existed here, much as we wonder today about those who might have come before us. In this way, the anomalies in Earth's past are mirrors. They reflect back not only the mystery of what might have been, but also the fragility of what we are now. They remind us that time is vast, civilizations are temporary, and the Earth is always patient, always recording, always carrying its secrets into the future. Chapter 8. Reflections on Lost Civilizations. What they teach us about ourselves. As we drift gently through the quiet corridors of deep time, imagining civilizations that may have risen and vanished long before humanity, we begin to notice something subtle but profound. These thoughts are not only scientific, they are deeply philosophical, almost meditative. They invite us to reflect on what it means to be intelligent, to build, to exist, and ultimately to leave a mark. Consider for a moment the sheer scale of time. The Earth is 4.5 billion years old. Humans have existed for a mere 300,000 years, a blink in the cosmic record. And yet in that short time we have built, explored and transformed the planet in ways that no species before us has. Even so, our monuments and cities, as enduring as we feel they are, will one day be erased by ice, erosion, and tectonic shifts. Thinking about civilizations that may have come before us invites a humbling perspective. They remind us that intelligence is not the same as permanence. The civilization can flourish, achieve remarkable feats, and then vanish completely, leaving only faint chemical or geometric whispers behind. It teaches us patience, humility, and awe in the face of Earth's vast processes. Culturally, the idea of lost civilizations resonates deeply across human history. Myths of Atlantis, Lemuria, and other vanished worlds are found in many societies. These myths, whether literal or allegorical, reflect a universal awareness that civilizations are fragile, and that knowledge, culture, and memory are not guaranteed to survive. They remind us that humanity is part of a continuum, not the center of the story, and that the past is far richer and stranger than we often allow ourselves to imagine. Philosophically, this speculation also challenges the way we define civilization itself. We tend to measure it by monuments, cities, or technologies, but perhaps intelligence can express itself in subtler ways. A species might create beauty without leaving stone ruins, or share knowledge without written language. They might cultivate ecosystems with care, or organize societies that leave no clear footprints. This encourages us to broaden our understanding of what it means to be civilized, and to recognize that our standards are human-centric, not universal. The contemplation of lost civilizations also offers a mirror for the present. If we think that civilizations can vanish entirely, erased by forces beyond their control, then we gain a perspective on the impermanence of our own world. Human civilization has grown in complexity and scale, yet it is vulnerable to climate shifts, natural disasters, and environmental degradation. In a sense, imagining lost civilizations is a form of meditation. It allows us to appreciate our achievements while remaining aware of their fragility. This reflection also opens the mind to creativity and wonder. Scientists often emphasize caution and skepticism, but imagination is an equally important tool for discovery. Many breakthroughs begin with a thought experiment. What if things were different? What if the world we see is only a fragment of what once existed? Speculating about non-human civilizations encourages curiosity, inviting us to see Earth as a story still unfolding, filled with mysteries waiting to be uncovered. There is also a sense of continuity in this meditation. If civilizations have risen and fallen before us, we are part of a chain, a vast tapestry of life and intelligence. We may be the latest contributors to Earth's story, but we're not the only ones. This perspective can be both humbling and comforting, reminding us that the planet is a living, dynamic entity, and that we are participants in a history much larger than ourselves. Finally, Imagining lost civilizations nurtures a sense of patience and wonder. It encourages quiet observation, noticing subtle patterns in nature, recognizing anomalies in rock layers, or pondering the mysteries hidden in oceans and deep forests. It reminds us that not all knowledge is immediate, not all secrets are revealed quickly, and that sometimes simply opening the mind to possibility is a profound form of discovery. In this way, the thought of civilizations before humanity becomes more than a speculative exercise. It becomes a meditation on impermanence, intelligence, creativity, and the deep patience of the earth. As we explore these ideas, we begin to appreciate both the fragility and resilience of life, the fleeting beauty of culture, and the vastness of time in which all stories, human or otherwise, are written. So, as we lie back and allow our minds to wander through these silent echoes of deep time, we realize that imagining lost civilizations is also a way to honor the Earth itself, to marvel at her age, her processes, and her secrets. It is a quiet, reflective journey, a gentle reminder that we are part of something far greater than ourselves, and that curiosity and wonder are timeless companions on this path. Chapter 9 Traces in Myth and Memory, Interpreting Ancient Knowledge. As we continue our quiet journey through the hidden past of Earth, we now turn our attention to another fascinating dimension, the stories and myths that humans have passed down for millennia. These are not physical traces, yet they may carry echoes of knowledge, experience, or memory that reach far deeper into time than we often realize. Every culture has its legends of lost worlds, ancient civilizations, and beings of great intelligence. In Greek mythology, there is Atlantis, a powerful kingdom said to have sunk beneath the sea. In South America, the tales of Paititi and hidden cities of gold whisper of civilizations that once flourished, only to vanish. Across Asia, Africa, and the Pacific, similar stories appear, civilizations erased, knowledge lost, and warnings encoded in myth. While scholars often interpret these stories symbolically, some propose a more intriguing possibility, that myths may preserve faint recollections of real events. Perhaps, in a distant past, Earth witnessed societies or intelligences unlike our own. Human imagination might have retained fragments of these memories, transforming them over generations into legend, metaphor, or cautionary tale. Consider the possibility that myths describe interactions with non-human civilizations, tales of gods, spirits, and beings with extraordinary intelligence appear across cultures. Could some of these stories reflect encounters with entities whose presence left lasting impressions on early humans? Perhaps they observed structures or patterns in nature that seemed too deliberate to be random, or witnessed environmental manipulations beyond their understanding, which were then passed down as sacred stories. Anthropologists have long noted similarities in myths worldwide. Flood stories, for instance, appear in Mesopotamia, India, the Americas, and beyond. While many of these are interpreted as reflections of localized floods, one could also imagine a distant collective memory, an echo of a time when a civilization, human or otherwise, faced a catastrophic event, its knowledge and culture lost to water, wind, and time. These stories may act as fragments of historical memory, encoded in narrative rather than written record. Beyond myths, there are ancient technologies hinted at in early texts. Some cultures describe machines, flying devices, or monumental constructions that seem far ahead of their era. While mainstream scholars often view these accounts as allegorical or misinterpreted, the idea of a prior civilization with knowledge we cannot yet fully comprehend remains compelling. Perhaps remnants of their achievements influenced the early development of human culture, subtly shaping architecture, engineering, and social organization in ways that were later mythologized. Human memory is imperfect, yet it is astonishingly resilient. Stories endure long after physical traces vanish. Oral traditions, songs, and rituals preserve knowledge across generations. Could it be that the faint memory of a non-human civilization, lost to stone, metal, and soil, survived in the human mind, filtered and transformed, but still recognizable to those willing to look closely? We also see these ideas reflected in geometric and symbolic patterns in ancient cultures. From the Nazca lines in Peru to megalithic structures in Europe, humans have created large-scale designs whose purpose often remains mysterious. Some researchers speculate that these designs may encode astronomical, environmental, or even memory-based knowledge. Could some of these patterns be influenced indirectly by knowledge left behind by a civilization that predated humans? While speculative, the thought invites careful reflection on how knowledge can be transmitted across vast spans of time, even in the absence of physical artifacts. It is worth noting that interpreting myths and symbols requires caution. Human imagination is extraordinarily creative, and coincidence can produce striking patterns. Yet the recurrence of similar themes, lost civilizations, sudden floods, advanced beings, and unusual constructions, across disconnected cultures is difficult to ignore. Whether these accounts describe literal events, symbolic truths, or echoes of unknown civilizations, they provide a rich landscape for contemplation, linking imagination, memory, and scientific inquiry. In this sense, myths act as mental fossils. Just as a geologist examines rock layers for evidence of lifelong vanished, we can examine human stories for glimpses of something extraordinary in the distant past. And like physical fossils, these stories are incomplete, fragmented, and often obscured, but they are still part of the record, waiting to be read with care and curiosity. As we meditate on these possibilities, a profound thought emerges. The Earth does not reveal all its secrets at once. Time, memory, and imagination weave together to preserve fragments of knowledge in ways we may only begin to understand. Lost civilizations, human or otherwise, may have shaped the world subtly, leaving traces that persist not just in rocks or oceans, but in the minds and stories of those who came after. And so, as we reflect quietly, we realize that searching for lost civilizations is not only a scientific endeavor, it is a meditation on history, memory, and the delicate connections between life, intelligence, and the Earth itself. Every story, every myth, every anomaly in the rocks becomes a window into a possible past, inviting us to wonder, to imagine, and to listen closely to the whispers of deep time. Chapter 10. Speculating on form and function, what a non-human civilization might have been. As we continue our quiet journey through the echoes of deep time, we begin to imagine not just the traces left behind, but the civilizations themselves, the beings who might have shaped the Earth before humanity arose. To do this, we must free our minds from the familiar shapes of cities, machines, and societies as we know them. What might a non-human civilization look like? How might it live, organize itself, and interact with its environment? First, consider form. Civilization is not necessarily tied to bodies like ours. Intelligence could take many shapes. Imagine a species adapted to the oceans, beings with flexible, resilient forms, perhaps capable of communicating through sound, light, or bioluminescent patterns. Their cities might resemble living reefs, where structures are grown rather than built, shaped from coral, sponge-like materials, or other biological matter. These organic cities would integrate seamlessly into their environment, providing shelter, pathways, and communication networks in ways humans would barely recognize. On land, we might imagine creatures that are highly social and collaborative, perhaps insect-like, operating in massive colonies where the needs of the group shape behavior rather than individual desire. These civilizations could build enormous functional structures from plant fibers, minerals, or soil, forming sprawling complexes that echo natural patterns like honeycombs or termite mounds. Their knowledge would be encoded in their environment, in living structures that change and grow over time, rather than in static libraries or archives. Technology, too, could differ radically from our expectations. Non-human civilizations might rely on biotechnology rather than metallurgy. They could manipulate life itself to create tools, transport systems, or energy sources. Imagine trees engineered to store water or energy, fungi cultivated to purify soil, or coral networks that act as both habitat and communication grid. Energy might not come from fire, electricity, or nuclear reactions, but from harnessing natural currents, chemical gradients, or even planetary heat. Such technologies could leave only subtle traces, chemical signatures, or structural patterns, easily hidden from our modern eyes. Social organization could also diverge dramatically from human norms. Non-human civilizations might function without hierarchies as we know them, instead relying on collective intelligence. Decisions could emerge from the interactions of countless individuals, coordinated through signals, vibrations, or biochemical cues. Cultural knowledge would not be written, but embedded in behavior, architecture, and the environment itself, a living archive that evolves with each generation. Communication might be another area of wonder. While humans rely on sound, symbols, and language, a non-human civilization could have used other senses entirely. Perhaps they communicated through subtle changes in color, patterns of movement, or electromagnetic pulses. Their literature might have been dynamic, ephemeral, and deeply tied to their habitats. Imagine a city whose very forests, rivers, and hills change rhythmically to encode knowledge, creating a landscape of meaning that humans could only perceive faintly. There is also the possibility of technological spiritual integration. Many human civilizations have tied knowledge and technology to ritual, art, and belief. A non-human civilization might have done the same, shaping entire ecosystems to reflect both practical and symbolic purposes. Perhaps forests were living libraries, mountains were energy collectors, and rivers served as both transport and information conduits. Their entire world could be a form of art, science, and spirituality combined, leaving behind traces that appear natural to us, yet are deeply deliberate. We can also imagine lifespans and perception affecting their civilization. If these beings lived longer than humans, their projects could span centuries or millennia, leaving structures and patterns that evolve slowly and harmoniously with the Earth. If they perceive time differently, their societies might operate on scales that seem almost eternal to us, with planning and memory embedded in generational cycles rather than individuals. Even conflict and cooperation might differ. Without the same drives for territoriality or conquest as humans, their civilizations may have evolved around harmony with the environment, rather than domination. Wars, if they existed at all, might be ecological in nature, reshaping landscapes through strategic cultivation, or controlled resource allocation rather than violence. Finally, consider the possibility of disappearance. Unlike humans, whose ruins remain for millennia, these civilizations might have built with materials that decay naturally, leaving no obvious structures for us to find. Entire societies could vanish quietly, their knowledge absorbed back into ecosystems, leaving only subtle traces in chemistry, isotopes, or fossil patterns. Their memory would be written into the Earth itself in ways that take careful, imaginative observation to detect. Through all this, one realization becomes clear. If non-human civilizations existed, they may have been profoundly different from us, yet their impact could still resonate in ways subtle and hidden. They remind us that intelligence is not uniform, that civilization can take forms beyond our imagination, and that Earth's history is richer and stranger than we often allow ourselves to believe. As we drift deeper into this thought, we find a quiet wonder in imagining not just our own history, but a prelude to it. An Earth filled with life, intelligence, and civilization in forms we may never fully comprehend, yet whose traces might still lie quietly beneath the surface, waiting for the curious and patient to notice. Chapter 11. Shaping the World. Environmental imprints of lost civilizations. As we drift further into the depths of speculation and science, a question arises. If non-human civilizations once existed, how might they have interacted with the world around them? What subtle imprints could their presence have left on the planet's environment long before humans ever walked the Earth? Understanding this allows us to imagine the profound interplay between intelligence and ecology, a relationship that may have shaped Earth in ways we're only beginning to grasp. Civilizations by nature alter their surroundings. Humans clear forests, build dams, mine metals, and cultivate fields. But non-human intelligences might have approached the environment differently, leaving marks that are less obvious but no less significant. Imagine a civilization that lived in harmony with ecosystems, intentionally guiding the growth of plants and the flow of rivers. Perhaps they cultivated forests like living cities, pruning, grafting, and shaping trees to create sustainable habitats. The architecture of their world would not have been stone or steel, but living, breathing organisms adapted over generations. In oceans, this effect could have been even more profound. Aquatic civilizations relying on bioluminescence and currents might have engineered coral reefs not only for shelter, but also to regulate local ecosystems. These structures could influence water chemistry, nutrient cycles, and even fish populations, effectively acting as living laboratories of ecological management. Over millennia, such interventions could subtly steer the evolution of marine life, leaving patterns in species diversity that persist long after the civilization itself disappears. On land, insect-like or collective species might have influenced soil formation, plant propagation, and the migration of other creatures. Termite mounds today are small examples of ecosystem engineering. They aerate soil, redistribute nutrients, and even affect microclimates. Multiply such activities across vast continents and long time scales, and the impact of a non-human civilization could be deeply embedded in Earth's geological and biological record, invisible to casual observation but detectable by careful study. Even atmospheric changes are possible. If a civilization used chemical processes, domesticated certain plant species, or engaged in controlled burns or other land modifications, they might have altered gas compositions, oxygen, carbon dioxide, methane, in ways that would leave long-term signatures. Some scientists studying ancient climate shifts have noted anomalies in gas ratios and isotopes that do not always fit neatly into known natural patterns. Could these be traces of intelligent intervention? While purely speculative, it is a possibility worth contemplating. Let us also consider extinctions and population shifts. Intelligent species, even those aiming for harmony, inevitably influence the survival of other species. Selective cultivation, introduction of new predators, or environmental modifications could accelerate the extinction of some species while promoting the proliferation of others. The fossil record might contain subtle hints of such influence. sudden changes in species abundance, shifts in dominance, or the rapid emergence of certain traits in flora and fauna. A particularly intriguing idea is genetic guidance. Advanced non-human intelligence might have manipulated evolution directly. They could encourage the development of certain traits in plants or animals, creating ecosystems that functioned more efficiently or symbiotically with their civilization. Over millions of years, this guidance might leave enduring patterns in the genomes of living species, quietly hinting at an intelligence that existed long before humans arrived. Even seemingly mundane features of Earth, river paths, lake formations, or mountain terraces, could bear the subtle fingerprints of ancient civilization. By carefully managing erosion, water flow, and sedimentation, intelligent species could shape landscapes to suit their needs, much like humans terraform land today. Over deep time, these subtle alterations might become indistinguishable from natural processes, yet still represent deliberate manipulation. This perspective transforms our understanding of Earth's history. The planet becomes a palimpsest, a layered canvas of natural and artificial influences intertwined across eons. Every forest, reef, and valley might contain whispers of past intelligence, woven so seamlessly into the environment that they appear entirely natural. Contemplating these possibilities also changes how we view our own civilization. We see ourselves as dominant, but Earth has a long memory. Subtle interventions, even if harmonious, can ripple across species and ecosystems. A lost civilization might have shaped the world without leaving towering monuments, yet their influence could still echo through life itself, through species distributions, chemical signatures, and landscapes subtly molded to support life in ways we're only beginning to detect. And so, as we imagine these long-gone civilizations, a quiet appreciation emerges, not only for their ingenuity, but for the resilience and patience of the Earth itself. The planet preserves memory in rocks, ice, soil, and the very DNA of living beings, waiting for those with patience and curiosity to interpret its deep, whispered story. Chapter 12. Communication and Navigation in Ancient Civilizations. As we continue to drift through the possibilities of Earth's deep past, we now turn our attention to an essential hallmark of any civilization: the to share knowledge, communicate, and navigate the world. Intelligence is not only the capacity to think individually, but to coordinate, transmit information, and connect across space and time. If non-human civilizations existed, their systems for knowledge and communication may have been profoundly different from ours, yet equally sophisticated. Let us imagine communication systems. While humans rely on sound, symbols, and written records, other intelligent species might have developed entirely different methods. Oceanic civilizations could have used the subtle vibrations of water or bioluminescent flashes to convey complex information across vast distances. In dense forests, species might have transmitted signals through chemical trails, changes in coloration, or rhythmic movements of leaves, bark, or other structures. Imagine a network of living signals, a language that blends environmental cues with deliberate patterns, capable of reaching hundreds of meters or even kilometers without leaving traces detectable to us. Communication may have extended to planetary scales. Civilizations deeply attuned to their environment could exploit natural systems, rivers, wind currents, electromagnetic fields to transmit information. Structures that appear natural to us, such as aligned mountain ridges, terraced plains, or unusual vegetation patterns, might have served as markers or signals within their network, guiding individuals or encoding information across generations. Their language could have been woven into the landscape itself. Navigation, too, might have been extraordinary. Humans navigate using stars, landmarks, compasses, or maps. A non-human civilization could have used far more integrated methods, sensing electromagnetic gradients, ocean currents, or subtle vibrations in the ground to traverse continents or oceans with precision. Imagine migratory patterns synchronized with environmental cues, allowing a species to move intelligently and sustainably across vast distances. Their maps could have been living ecosystems, where every river, forest or reef served as both guide and archive of knowledge. Consider also temporal networks of knowledge. While humans rely on writing, non-human species might encode memory biologically or environmentally. Genetic memory, passed through generations, could store vital information about habitats, climate patterns, or social structures. Similarly, living architecture, trees shaped to preserve chemical markers, fungi engineered to indicate soil conditions, or coral formations recording ocean chemistry, could serve as dynamic, evolving archives. Knowledge in this context is not static. It grows, adapts, and interacts with the environment continuously. Even social networks could be astonishingly sophisticated. Some species might have relied on collective intelligence, where decisions emerge from the interactions of thousands or millions of individuals. Signals from one part of a colony could ripple outward, guiding activity, optimizing resource use, and distributing knowledge efficiently. This form of intelligence, integrated into the life of the environment, might be virtually invisible to human observers, yet highly effective. The implications are profound. If such civilizations existed, much of their knowledge would leave no conventional evidence. There would be no stone tablets, libraries, or artifacts for us to discover. Instead, their wisdom would be embedded in chemistry, biology, and structure, encoded in ways that require careful observation, patience, and imagination to interpret. For example, a sudden bloom of a particular plant species in a fossil record, or an unusual arrangement of sedimentary deposits, might not be random. They could reflect intentional patterns, messages, instructions, or records created by an intelligence that saw the planet as a medium for communication. We can even speculate about intercontinental coordination. If the species were highly social and technologically advanced, they might have synchronized activities across vast regions. Think of migratory coordination, resource management, or ecological engineering executed at continental scales. These actions, subtle yet deliberate, could leave faint but detectable imprints in Earth systems, traces of timing, energy use, or material redistribution that seem anomalous without an intelligent cause. And so, the picture emerges of civilizations that are radically different from our own, yet unmistakably sophisticated. Their cities, networks, and archives might have been alive, ever-changing, and inseparable from the ecosystems around them. Communication was not just about transferring information. It was about harmonizing with the planet, embedding knowledge in life itself, and ensuring that their civilization could persist across generations, even in ways humans could scarcely recognize. As we meditate on these possibilities, a quiet realization surfaces. Intelligence and civilization do not require stone or metal to exist. They require organization, communication, and memory, and the planet itself can serve as the medium. Perhaps, somewhere in the chemical, biological, and structural record of Earth, faint traces of these networks remain, waiting for patient eyes and minds to perceive them. Chapter 13. How Lost Civilizations Might Have Shaped Evolution. As we continue our tranquil journey through the mysteries of Earth's deep past, we arrive at a subtle yet profound possibility that civilizations long gone, if they existed, might not have only inhabited the world, they might have shaped it. Life on Earth is a tapestry of interwoven species, ecosystems, and environmental processes. Could intelligence have guided, nurtured, or even altered this tapestry long before humans appeared? Let us begin with the idea of direct influence on evolution. Intelligent species could have, intentionally or unintentionally, affected which organisms thrived and which faded. By modifying habitats, redistributing resources, or cultivating particular species, they might have created selective pressures similar to those humans exert today, but far earlier and perhaps more subtly. Consider a hypothetical forest civilization. By favouring certain trees for structural or nutritional purposes, they inadvertently guide the evolution of those species, promoting traits like faster growth, resilience, or particular chemical compositions. Over millennia, these choices would leave enduring patterns in the fossil record, influencing plant and animal development. In the ocean, civilizations could have performed ecological engineering on reefs and marine life, constructing or guiding coral structures, regulating water flow, or managing populations of key species could subtly shape ecosystems. Certain fish, mollusks, or crustaceans might become dominant in response, while others decline. Fossil evidence might show these patterns as sudden shifts in diversity, distribution, or morphology, hinting at intelligent intervention rather than purely natural causes. The influence on genetic diversity could be profound. By selectively encouraging traits in plants or animals, a civilization might accelerate adaptation in ways that appear anomalous to modern scientists. Imagine a species of plant developing unusually rapid reproductive cycles, or a new defensive mechanism, patterns that might seem like natural mutations but are in fact guided evolution. Similarly, large-scale modifications to land, rivers, or climate could create selective pressures that favour certain traits in animals, subtly altering ecosystems over geological timescales. Behavioural evolution might also bear their mark. Intelligent species could teach, guide, or encourage particular behaviours in other life forms. Birds, mammals, or even insects could be influenced to create symbiotic relationships, perform ecological maintenance, or assist in resource management. Fossilised evidence of cooperative behaviour, migration patterns, or unusual nesting practices might be legacies of these interactions, encoded in the habits of species we see today. Consider too the shaping of microenvironments. Soil chemistry, nutrient cycles, and microbial populations could be carefully balanced to promote life that supports the civilization. Perhaps certain fungi were cultivated to enhance soil fertility, or bacterial colonies guided to recycle nutrients efficiently. Over millions of years, these engineered microenvironments would leave detectable chemical or isotopic signatures in rock and sediment, faint whispers of intelligent stewardship embedded deep in the earth. Some researchers also consider large-scale environmental modifications. Imagine terraces along hillsides to manage water flow, artificial ponds to stabilize microclimates, or underground networks that redirect groundwater. Such interventions could create pockets of biodiversity uniquely adapted to these altered conditions. While these changes might appear natural over millennia, careful study could reveal subtle patterns inconsistent with random geological or biological processes. Even in extinction events, non-human civilizations might have played a role, not through malice, but through ecological engineering. The disappearance of certain species could result from habitat modification, introduction of new predators, or changes in nutrient cycles, actions that simultaneously benefit other organisms. In this sense, a lost civilization might act as both gardener and architect of life, guiding ecosystems toward resilience, efficiency, or stability, while leaving traces only perceptible to those patient enough to decode them. The most profound idea of all is perhaps intelligence integrated with evolution itself. Unlike humans, who often act in isolation from natural cycles, a non-human civilization might have understood the balance of life deeply, embedding their knowledge into the very processes of evolution. They would not simply consume resources, they would orchestrate life, shaping species, habitats, and ecological relationships across continents and oceans, leaving Earth richer, more complex and more resilient than it might have been otherwise. In this chapter of imagination and science, we begin to perceive Earth not merely as a backdrop for life, but as a living canvas shaped by forces both natural and intelligent. Fossils, isotopes, ecosystems, and genetic patterns may carry subtle signatures of civilizations that worked quietly alongside nature, leaving their influence embedded in the very DNA of the planet. And as we reflect quietly on these possibilities, a gentle awe settles in. The Earth may have been a stage for intelligence long before humanity, with civilizations that shaped life in ways profound and enduring. In the silence of rocks, the whispers of oceans, and the patterns of life itself, the memory of these ancient architects might still linger, awaiting discovery. Chapter 14. Memory and Matter, Recording Time and History. As we continue this quiet journey into the hidden depths of Earth's past, we now consider a profound question. How might a civilization that existed long before humans have recorded its history and knowledge? Without paper, ink, or digital technology, the memory of a non-human civilization would need to exist in forms integrated with the planet itself, biological, environmental, and geological. And in these forms, their legacy could persist hidden in plain sight, waiting for discovery. Let us first explore biological memory. Some species encode information genetically, passing survival strategies, behavioral patterns, and adaptations across generations. A highly intelligent civilization could have deliberately influenced this process, guiding evolution to carry knowledge forward. Plants might carry chemical signals that instruct growth or interaction with other species, while animals might inherit behaviors optimized for ecological harmony. In this sense, memory becomes living, dynamic, and self-perpetuating, a library written into the very fabric of life. Beyond biology, environmental structures could act as long-term archives. Imagine forests shaped with deliberate patterns, where the placement, size, and type of trees encode complex information. Rivers might be diverted to mark seasons, astronomical events, or cycles of resource availability. Coral reefs, sediment layers, or underground fungal networks could store data about water quality, climate, or ecological balance. Such environmental memory would not be static. It would evolve with the planet, providing both record and ongoing function. Geology, too, might serve as a medium of history. Consider terraces, mounds, or unusual rock formations carefully constructed to survive erosion and geological shifts. Minerals could be manipulated or deposited in ways that mark significant events, while isotopic variations in sediments might reflect deliberate changes in chemical processes. Even the placement of boulders, patterns of erosion, or underground cavities could serve as markers of time and achievement. Over millennia, these geological archives would blend seamlessly with natural processes, leaving traces subtle yet enduring. Some speculative thinkers imagine civilizations using light, sound, or vibration as long-term records. Bioluminescent patterns in plants, rhythmic movements of organisms, or vibrations transmitted through water, soil, or air could encode information, repeating signals across generations. These methods would leave ephemeral traces, but in systems designed for stability, patterns might persist in environmental cycles or even in genetic memory, creating multi-layered archives of knowledge. Another possibility is the recording of astronomical cycles. Early humans aligned structures with solstices, equinoxes and star patterns to track time. Non-human civilizations might have done the same on a far larger or more integrated scale. Mountain alignments, river courses, or vegetation patterns could mark celestial events, providing both calendars and navigational references. Unlike human monuments, these systems would evolve naturally, continuously renewing their accuracy and relevance across thousands or millions of years. Memory could also be encoded in ecosystems themselves. If civilizations carefully managed predator-prey relationships, plant dispersal, or water flow, the patterns of life across a region could reflect intentional design. Scientists examining species distributions might detect anomalies, gaps, clusters, or unusual sequences that hint at guidance by intelligence rather than randomness. In this way, memory is not written in symbols but lived in the ongoing interactions of life. Even disasters could be part of memory systems. Strategic flooding, controlled fires, or other environmental resets might serve as reminders, timestamps, or calibration events for knowledge networks. While destructive from one perspective, these events could preserve long-term ecological balance, encode lessons, or mark transitions in the civilization's timeline. What emerges from these reflections is a vision of history that is deeply entwined with life and Earth itself. Time is not measured in pages or digital storage, but in growth rings, sediment layers, river bends, and genetic codes. Memory is not confined to libraries or museums, but flows through the living world, dynamic, adaptive, and resilient. For a non-human civilization, survival and record-keeping are inseparable from their environment, a harmonious integration of life, knowledge, and planet. As we meditate on this possibility, a quiet realization settles in. The Earth itself may be the ultimate archive. Beneath our feet, within the forests, reefs, soils, and ice, memory may persist from civilizations lost to time. Interpreting these subtle traces requires patience, imagination, and humility. But the reward is profound. A glimpse into intelligence that existed long before humanity, leaving its wisdom embedded in the planet's living and non-living systems. Chapter 15. Why lost civilizations might have disappeared. As we continue our serene journey through Earth's deep past, a natural question arises. If non-human civilizations once existed, why are they no longer present? Their absence is as telling as their traces. Understanding the potential causes of their disappearance invites both scientific contemplation and gentle reflection on the fragility and impermanence of intelligent life. One possibility lies in environmental change. Earth is a dynamic planet, constantly reshaped by tectonic movements, volcanic eruptions, glacial cycles, and shifting climates. Even the most resilient civilization could be challenged by dramatic changes over thousands or millions of years. Rising seas might submerge coastal habitats, while prolonged droughts could force migration or resource depletion. A civilization attuned to its environment might survive gradual shifts, but rapid or extreme events, massive volcanic eruptions or asteroid impacts, could overwhelm even the most sophisticated adaptations. Biological factors also play a role. Predation, disease, or competition could erode populations, especially if species relied on tightly integrated ecological networks. A subtle imbalance, loss of a key species, collapse of a food source, or introduction of a pathogen might ripple through the ecosystem, destabilizing entire societies. Unlike humans, who can sometimes artificially compensate for ecological disruption, these civilizations may have depended entirely on natural equilibrium, making them vulnerable to cascading changes. Cosmic influences are another possibility. Earth is constantly bombarded by meteorites, cosmic radiation, and solar fluctuations. While catastrophic collisions are rare, even smaller events could disrupt habitats, trigger climate anomalies, or cause widespread environmental stress. A civilization reliant on delicate environmental balances might face existential threats from forces entirely beyond its control. Internal dynamics could also contribute. Societies, no matter how intelligent, are vulnerable to overextension or miscalculation. Resource management might fail, collective decision-making could falter, or unintended consequences of ecological engineering might accumulate over generations. Even a civilization deeply integrated with its environment might face collapse if environmental, biological, or social stresses converge. The concept of voluntary departure is also worth considering. Some civilizations might have intentionally retreated from active influence, choosing to blend with the environment rather than persist visibly. Perhaps they integrated so fully with ecosystems that their material presence disappeared, leaving only traces in genetic, chemical, or structural records. Their disappearance might not be catastrophic in the traditional sense, but a deliberate shift towards sustainability and invisibility. Evidence of these departures might be subtle. Chemical anomalies in sediments, shifts in isotopic ratios, sudden changes in species abundance, or unusual fossil patterns could reflect the disappearance of intelligent management long before humans appeared. These signs are faint but persistent, like echoes of a civilization fading into the deep memory of Earth itself. Even their cultural or knowledge systems might vanish quietly. Without humans to interpret them, patterns encoded in living architecture, genetic memory, or environmental design could be lost, leaving only the faintest hints. Knowledge might survive indirectly, as altered evolutionary paths, modified ecosystems, or unusual geological formations, cryptic reminders of presence without direct recognition. The vanishing of such civilizations also invites reflection on human impermanence. Like them, humanity is intricately connected to the environment, subject to forces far larger than ourselves. Climate, geological processes, disease, and cosmic events all remain powerful influences. Imagining civilizations that once thrived and disappeared reminds us of the delicate balance required for longevity and the humility needed when interacting with a world as vast and complex as Earth. Ultimately, the disappearance of these civilizations may not represent failure, but a form of harmony. Perhaps their wisdom lay not in permanence, but in integration, in leaving behind a legacy embedded in life, geology, and memory, quietly shaping the world for eons to come. In this sense, their departure is a final lesson, that intelligence can leave lasting influence without lasting monuments, that survival is measured not in stone or metal, but in the enduring patterns of life itself. As we meditate on this quiet departure, a sense of awe settles in. The Earth is a vast archive, holding records of intelligence, adaptation, and disappearance. Every fossil, riverbed, coral reef, and soil layer carries hints of life, knowledge, and civilization that may have existed long before humans. Listening carefully, we can perceive these whispers, silent reminders that life, intelligence, and memory are intertwined in ways both delicate and profound. Chapter 16. Silent Encounters. Interactions between lost civilizations. As we continue our tranquil journey through the hidden corridors of deep time, we arrive at a compelling possibility that Earth may have hosted not just one, but multiple civilizations long before humans. Imagine a world where intelligence emerged in different forms, on land, in the oceans, and perhaps even underground, each species uniquely adapted to its environment. How might these civilizations have interacted? What subtle traces might such encounters have left for us to discover? In considering these interactions, it is important to remember the vast diversity of life. Land-dwelling species might have developed social structures, cities, and networks of communication, while oceanic civilizations thrived in fluid three-dimensional environments, navigating by currents, sound, and light. Other species might have lived underground, shaping vast networks of tunnels, chambers, and subterranean ecosystems. Each civilization would be shaped by its environment, yet the overlapping influence zones might lead to encounters, sometimes cooperative, sometimes competitive. Cooperation is one possibility. Civilizations could have shared knowledge about resource management, environmental patterns, or survival strategies. An oceanic society might influence coastal or riverine civilizations by guiding fish populations or nutrient flows, while terrestrial species provide stability to watersheds or pollination networks. Together, these interactions could create regional ecosystems of remarkable efficiency, balance, and resilience. The Earth itself becomes a canvas of co-created intelligence, where multiple civilizations shape environments in complementary ways. Competition, too, could have occurred, but not necessarily as violent conflict like human wars. In non-human civilizations, competition might manifest subtly, through environmental modification or resource allocation. One species could alter a river course to favour its own food sources, while another responds with changes in forest management or reef engineering. Over millennia, such ecological negotiations could leave detectable patterns in sediment, soil, and fossil records, interactions written not in stone monuments, but in the living world. Consider also cultural exchange. While communication might have been limited by sensory modalities, indirect interactions could occur through observation, imitation, or environmental signaling. For example, a species might notice patterns in another's construction, migration, or cultivation practices, integrating aspects into its own society. Over generations, these influences could propagate across continents, creating echoes of shared knowledge visible in biological or geological records. The overlapping presence of multiple civilizations could also explain anomalies in the fossil and environmental record. Sudden shifts in species abundance, unusual architectural structures, or chemical anomalies in soils might reflect the convergence of different intelligent influences, each leaving subtle complementary marks. These interactions would be complex, woven into the rhythms of life, and largely invisible to modern observers, detectable only through patient study and careful interpretation. Interactions could also involve temporal coordination. Civilizations with different lifespans or perceptions of time might synchronize activities in unexpected ways. Long-lived species might adjust their engineering or resource management cycles to coincide with shorter-lived species, creating overlapping systems of influence. The result would be a planet where multiple intelligences coexisted, each leaving enduring, interwoven patterns that survive as subtle imprints in Earth's living and non-living systems. Some scientists speculate that such interactions could extend to early planetary engineering. Civilizations could collaborate, intentionally or indirectly, to stabilize climates, manage ecosystems, or prevent catastrophic collapse. For instance, oceanic species might regulate temperature or nutrient flows, while terrestrial species cultivate forests to stabilize soils and regulate atmospheric composition. Together, these activities could subtly shape the planet's evolution, making Earth more resilient and biologically diverse long before humans arrived. Conflict or cooperation might also have influenced migration patterns. Civilizations could adjust the distribution of species, the flow of water, or the growth of vegetation to manage territorial boundaries or resource access. These interventions would be subtle, leaving indirect evidence, such as unusual fossil distributions or rapid shifts in plant and animal populations. While no monumental wars might exist, the consequences of intercivilizational interaction would ripple through ecosystems over millennia. Even in disappearance, these interactions leave traces. When one civilization vanished due to environmental change, disease, or voluntary retreat, its influence might persist in another's territory, creating overlapping imprints in ecology, geology, and genetics. Fossils, isotopes, and sediment layers might preserve hints of these encounters, silent records of ancient diplomacy, competition, and collaboration between intelligences. As we reflect on these possibilities, a quiet sense of wonder emerges. Earth may have been a theatre of intelligence far richer than we imagine, where multiple civilizations, each uniquely adapted, shared, competed, and co-created environments across millennia. Their interactions, gentle, complex, and profound, remind us that intelligence is not defined by conflict or conquest alone, but by influence, adaptation, and harmony with the living planet. Chapter 17. Echoes in Earth's Fabric. Chemical and Mineral Traces of Lost Civilizations. As we continue our calm exploration of Earth's deep past, we arrive at a fascinating possibility that civilizations, intelligent and advanced, may have left traces in the very chemistry and mineralogy of our planet. Unlike monuments or artifacts, these traces are subtle, persistent, and woven into Earth's natural systems, offering a quiet record of influence for those patient enough to discern it. First, consider chemical footprints. Every civilization, no matter how harmonious, interacts with its environment. Water management, waste processes, cultivation, and even biochemical signaling all leave chemical residues. Imagine an aquatic civilization regulating a reef system. Its bioluminescent organisms, metabolic byproducts, and controlled nutrient flows could alter local water chemistry over centuries. Even after the civilization vanishes, these chemical shifts, slightly altered ratios of nitrogen, phosphorus, or trace metals, might persist in sediment layers, telling a silent story of intelligent intervention. On land, soil composition could carry lasting markers. Civilizations that cultivated forests, pruned landscapes, or engineered agriculture would influence nutrient cycles, pH levels, and microbial populations. Over millennia, these changes could be captured in isotopic signatures, fossilized plant matter, or preserved microbial communities. Such chemical markers are often subtle, easily overlooked, yet they endure far longer than physical structures. Minerals themselves might be subtly shaped. Certain civilizations could manipulate naturally occurring minerals for building, signaling, or functional purposes. For example, a society might concentrate specific clays, metals, or crystalline structures to create living architecture, energy conduits, or environmental sensors. Once these structures degrade, the mineral distributions remain, creating unusual formations or isotopic anomalies that hint at intelligent design, rather than purely natural processes. Even the atmosphere could bear traces of these civilizations. By influencing plant growth, water cycles, or ocean chemistry, they might have altered local or even regional gas concentrations. Slight shifts in carbon dioxide, oxygen, methane, or other gases could be recorded in ice cores, sediment layers, or stalagmites, providing clues to environmental manipulation. Over geological timescales, these atmospheric fingerprints may remain, waiting to be interpreted. Another intriguing possibility lies in chemical signaling networks. Some intelligent species might have used biochemical markers as a form of communication or memory, dispersing substances into soil, water, or air to convey information across generations. Certain fungal or microbial colonies could act as living archives, retaining data in their chemical structure. Even long after the civilization itself disappears, these microbial messages might persist, encoding a quiet record of knowledge and activity. Trace metal manipulation could also provide subtle evidence. Metals concentrated, alloyed, or deposited in unusual ways could indicate deliberate intervention. Perhaps a civilization redirected iron-rich sediments to shape waterways or influence soil fertility, or accumulated copper or other minerals for functional or symbolic purposes. These subtle alterations could survive erosion, fossilization, or sedimentation, providing enduring hints of intelligent design in the mineral record. Consider hydrological interventions. Civilizations that managed water flow, redirecting rivers, creating terraces, or engineering wetlands, might leave traces in sediment deposition, erosion patterns, or isotopic signatures of water sources. These interventions could influence plant and animal distributions, leaving cascading effects detectable millions of years later. Even subtle modifications repeated across generations could imprint enduring chemical and geological signals across landscapes. Interestingly, chemical and mineral traces might overlap with biological signatures, creating a multi-layered record. For example, altered soil chemistry could promote the growth of certain plants, which in turn shape animal behavior and population dynamics. Together, these effects form a complex mosaic of environmental influence, where chemistry, biology, and geology converge to record the presence of intelligence. Finally, even subtle anomalies, such as unusual isotopic ratios in fossils, rare mineral concentrations, or layered chemical markers, might indicate intentional management of Earth systems. While not immediately obvious, these signals could be interpreted by careful analysis, revealing whispers of civilizations that lived in harmony with their planet, leaving enduring echoes in the very fabric of Earth. Through this lens, we begin to see Earth as more than a passive backdrop for life. It is a responsive archive, holding chemical and mineral memories of intelligence long before humans arrived. These subtle traces offer a profound lesson. Even without towering monuments, civilizations leave marks that endure, quietly shaping the planet in ways that only the patient and perceptive can detect. Chapter 18. Whispers in Stone. Fossils and biological patterns as evidence. As we continue our serene journey through the deep past of Earth, we arrive at perhaps the most tangible, yet quietly enigmatic traces of life. Fossils. Fossils are the time capsules of our planet, preserving the shapes, structures, and even behaviors of organisms that lived millions of years ago. Yet what if, within these ancient records, there exist subtle hints of intelligence that predated humanity? What if certain patterns in fossils or unusual biological behaviors are echoes of civilizations long vanished? We begin with unusual behavioral fossils. Trace fossils, such as burrows, footprints, or feeding marks, capture actions, not just forms. While many of these are naturally explainable, some might suggest patterns too complex or organized to arise randomly. For instance, large-scale arrangements of burrows, tunnels, or nests in perfectly aligned patterns could indicate collective intelligence at work, perhaps even early forms of social engineering or environmental management. Fossilized structures in soil, rock, or sand might reveal intentional shaping of habitats or resource networks. Consider also anomalous species distributions. Paleontologists sometimes encounter abrupt changes in species prevalence, sudden bursts of diversity, or rapid emergence of unusual traits. While natural selection provides one explanation, an intelligent influence, through selective cultivation, environmental modification, or ecological guidance, could also be at play. Perhaps a particular species thrived due to careful ecosystem engineering, while others diminished under pressures applied subtly by advanced beings. Over millennia, these patterns could fossilize, leaving faint but detectable imprints of deliberate influence. Fossilized plant life may provide equally compelling evidence. Some ancient forests and flora show highly regular spacing or unusual growth forms that deviate from what natural competition would produce. Imagine a civilization guiding forests to serve functional or aesthetic purposes, trees arranged to manage water flow, control soil erosion, or encode information. Over time, these arrangements could fossilize as unusually patterned roots, stumps, or pollen deposits, capturing a whisper of intent from the distant past. Marine fossils too tell a story. Coral reefs, shell beds, and sediment layers can preserve hints of ecosystem manipulation. Certain reefs exhibit layering patterns or growth sequences that do not fit purely natural models, suggesting careful environmental management. The selective proliferation of particular species, whether corals, shellfish, or plankton, might leave detectable isotopic or morphological anomalies in the fossil record, hinting at intelligent guidance in marine environments. Some fossils may even record genetic intervention or behavioral transmission. Species that display sudden, coordinated adaptations or unexpected traits may have been influenced by external intelligence, intentionally or indirectly. For example, changes in limb structure, feeding patterns, or social behaviors preserved in the fossil record could reflect guidance in evolution, subtle nudges that accelerated adaptation or promoted ecological balance. Fossilized mass movements of organisms also offer intriguing possibilities. Large gatherings of creatures, preserved together in sediment layers, could reflect more than natural phenomena. While floods or volcanic events can explain some patterns, others, remarkably structured or repetitive arrangements, might indicate orchestration, migration guidance, or resource distribution influenced by intelligence. Even trace evidence of underground or burrowing species shows patterns that suggest collective, purposeful activity. We can also consider long-term ecological patterns preserved in fossils. Fossilized pollen, seeds, or plant matter embedded alongside animal remains can reveal ecosystems that were deliberately cultivated or managed. Repeated sequences, precise spacing, or synchronized cycles might hint at environmental guidance. Across millennia, such interactions between species influenced by intelligence could leave detectable imprints, an intertwined story of life, intelligence, and environment frozen in stone. Finally, the intersection of fossils and chemical markers provides a multi-layered archive of evidence. Certain fossil sites show isotopic anomalies, unusual trace metals, or altered mineral deposits alongside preserved organisms. These anomalies may suggest environmental management, selective cultivation, or other forms of intelligent influence. When studied together, fossils, isotopic signatures, and mineral traces create a subtle but compelling record, an archive of life shaped by forces that go beyond natural selection alone. As we meditate on these possibilities, a gentle realization emerges. Fossils are not just remnants of life. They may also be records of intelligence, encoded in behavior, structure, and environmental context. Each trace fossil, each unusual pattern, carries a whisper from the past, inviting us to consider that the story of life on Earth may be intertwined with civilizations that existed long before humanity. Through this lens, Earth itself becomes a living library, where stone, sediment, and fossilized life preserve not only the story of evolution, but also hints of intelligence, guidance, and environmental stewardship. Listening carefully, we can perceive these whispers, quiet yet profound, echoing across millions of years. Chapter 19. The Tools of Silence. Technology in Lost Civilizations. As we continue our calm journey through the possibilities of Earth's ancient past, we come to a question both fascinating and subtle. What technologies might these civilizations have developed? Unlike humans, whose inventions are often visible in monuments, machines, or digital records, non-human civilizations may have crafted tools and technologies integrated seamlessly with their environment. Their ingenuity might have been quiet, sophisticated, and designed to endure invisibly within Earth's ecosystems. We begin with energy use. Any advanced civilization requires energy to manipulate its environment, sustain populations, and support social networks. Imagine species that harnessed natural energy flows, rather than burning fuel. Oceanic civilizations might have exploited tidal currents or thermal gradients to power mechanical or biological devices. Forest-dwelling societies could use wind currents or water pressure in rivers and streams to move materials, regulate microclimates, or circulate nutrients efficiently. Their energy systems would be adaptive, resilient, and harmoniously integrated into the natural rhythms of the planet. Tool creation in such civilizations could be equally sophisticated yet subtle. Rocks, minerals, or organic materials may have been shaped into functional objects, but unlike human tools, these items may degrade naturally, leaving faint traces. Tools might serve environmental engineering purposes, such as directing water flow, cultivating forests, or guiding animal behaviors. For instance, stones arranged to redirect river sediment, coral structures to influence currents, or fungal networks to control soil fertility. Each a tool carefully designed to shape ecosystems, rather than serve immediate personal needs. Construction and architecture may have been a blend of biology and engineering. Buildings or shelters could have been living structures, trees grafted and shaped over generations, coral and shell formations cultivated underwater, or subterranean chambers expanded through careful excavation and growth. Such architecture would be resilient, self-repairing, and integrated with ecosystems, leaving only faint geological or fossil traces over millennia. In a sense, the tools themselves are alive, evolving alongside the civilization. We can also consider transport and navigation technologies. Species adapted to different environments might develop subtle methods to traverse oceans, forests, or underground networks. Floating devices powered by currents, bioluminescent signaling for long-distance guidance, or natural tunnels engineered for rapid movement could serve as infrastructure for communication and travel. While no metal bridges or vehicles might remain, the traces of their design could persist in sediment layers, altered waterways, or unusually patterned geological formations. Environmental management would likely be a central focus of technology. Civilizations could develop precision tools for ecosystem engineering, directing plant growth, controlling animal populations, or regulating water and nutrient cycles. Imagine systems of weirs, terraces and channels designed to stabilize landscapes, or coral reefs sculpted to buffer coastlines. These technologies would be subtle yet highly effective, optimized over generations for resilience and sustainability rather than spectacle. Energy capture might also extend to biological systems. Some species could engineer symbiotic organisms to provide light, heat, or chemical energy. Bioluminescent algae might illuminate underwater cities, fungi could recycle waste into usable energy, and photosynthetic plants might be shaped to provide both nourishment and structural support. In this way, technology and biology merge seamlessly, creating functional systems that leave minimal conventional artifacts. Advanced information technologies may have existed, though unlike human writing or digital storage, they could be encoded in natural media. Chemical signals, genetic modifications, or environmental markers could store information across generations. Fungal networks, river systems, or living forests might serve as memory devices, transmitting knowledge and instructions quietly, yet with remarkable precision. Knowledge becomes embedded in the landscape itself, persistent even as individual members of the civilization vanish. Lastly, we can imagine defensive or protective technologies, not in the violent sense, but to maintain ecological balance or safeguard populations. Certain species might manipulate predator-prey dynamics, redirect resource flows, or shape habitats to protect vulnerable members. These interventions, while subtle, could leave long-lasting effects on ecosystems, reflected in patterns of species distribution, soil chemistry, or fossilized environmental arrangements. The overarching theme emerges. Technology in these civilizations is not about domination or conspicuous display. It is about harmony, efficiency, and longevity. Tools are not separate from life. They're extensions of intelligence, woven into the very fabric of Earth's ecosystems. Energy, construction, information, and environmental management are deeply integrated, leaving traces that are subtle but enduring. As we reflect on these possibilities, a quiet understanding takes hold. Civilizations that predated humanity may have been technologically advanced in ways that defy our conventional definitions. Their tools and energy systems may have been invisible to the casual observer, yet their impact could ripple across ecosystems, geology, and biological evolution, silent, profound, and lasting. Chapter 20. Eyes on the Sky. Cosmic Awareness of Lost Civilizations. As we continue this tranquil journey into the deep past, we turn our attention upward, toward the vast expanse of the cosmos. The night sky, with its stars, planets, and endless patterns, has inspired curiosity for all intelligent life. Even civilizations predating humans might have looked to the heavens, seeking understanding, guidance, and connection with the cycles of Earth and universe. Observing the cosmos would have been an extension of survival and environmental awareness. Celestial movements regulate seasons, tides, and climate, patterns crucial to the success of any civilization. Imagine an intelligent species on land, ocean, or underground, studying the patterns of stars to predict seasonal floods, plant growth cycles, or migratory behaviors. By tracking constellations, solar movements, or lunar phases, these civilizations could synchronize agriculture, migration, and resource management with precision long before humans formalized astronomy. Some civilizations might have developed remarkably precise observational methods. Mountain peaks, cliff faces, or coral formations could serve as natural observatories, aligned with solstices, equinoxes, or planetary events. Movable reflective surfaces, bioluminescent markers, or even arranged trees might create sightlines and measurement systems. Over generations, these alignments could form a quiet, persistent record of astronomical knowledge, encoded not in writing, but in landscape, structure, and memory. The oceans offer equally fascinating possibilities. Aquatic civilizations could track celestial positions through patterns in light, tidal variations, and currents. Bioluminescent organisms might have been used to mark positions, signal time, or transmit complex observational data. Even without paper or instruments, these species could develop sophisticated celestial maps, guiding navigation and environmental management. The movements of moons, stars, and planets would not only inform daily survival, but also inspire philosophical reflection and cultural significance. Underground or subterranean civilizations may have relied on indirect observations. They could infer cosmic patterns through environmental cycles, seasonal floods affecting underground rivers, changes in plant or animal behavior, or even subtle vibrations transmitted through rock and soil. By tracking these indirect indicators, civilizations could develop complex calendars, predict cycles, and coordinate social or ecological activities with astonishing accuracy. The study of the cosmos might also involve long-term records embedded in nature. Fossilized patterns, sediment layers, ice cores and coral rings could all serve as archives, capturing cyclical events like solar flares, meteor showers, or climate variations. Civilizations attuned to these records might have developed a form of proto-astrophysics, connecting events on Earth with cosmic phenomena and integrating this knowledge into environmental management, social organization, and cultural rituals. Cultural expression may have reflected this cosmic awareness. Songs, dances, or synchronized movements could encode observations of star positions or seasonal changes. Bioluminescent displays, intricate nest patterns, or flowing water arrangements might serve as visual records of celestial events. Over millennia, these artistic expressions would persist as subtle, environmental imprints, forming a living archive of cosmic knowledge. Interactions between multiple civilizations could also expand cosmic understanding. Observations from different ecological niches, land, ocean, or subterranean, might converge to provide a broader perspective. Coordinated or complementary observations could reveal complex patterns invisible to any single civilization, creating a collective intelligence that tracks cosmic rhythms across vast scales. Even in disappearance, the cosmic awareness of these civilizations could leave traces, alignments in landscapes, fossilized patterns of migration, or synchronized biological behaviors might encode information about past celestial events. Ice cores, sediment layers, and coral rings may preserve indirect markers of their observational systems. These imprints, subtle yet persistent, hint at a civilization whose curiosity extended far beyond survival, reaching into the infinite expanse of the universe. Ultimately, we're invited to imagine a world where intelligence was deeply attuned to both Earth and sky. Observing the cosmos was not merely scientific, it was practical, philosophical, and perhaps spiritual. Civilizations long before humans may have cultivated understanding of the heavens as part of a harmonious relationship with life and planet, leaving traces that ripple through ecosystems, fossils, and geological records. As we reflect quietly on these possibilities, a sense of wonder and calm emerges. The night sky may have inspired civilizations long vanished, guiding their lives, shaping their environments, and leaving whispers in stone, water, and living systems. Even now, the cosmos above us carries silent testimony to intelligence that gazed upward, in awe, long before humanity existed.